Activated Construction Crew, OG.
Our team number is
57576
or 15. And we are from
Clearwater, Florida.
My name is Bryce.
My name is Skylar.
My name is Eric.
My name is Ian.
My name is Bryce.
My name is Chris.
Judges, may we please begin?
So we started off this season by having a Scuba International member talk to us about a few problems they and their partnering organizations faced with ocean exploration. Each team member contributed to our Microsoft Whiteboard site, brainstorming ideas for potential research topics. We then went around the room and each team member spoke about the issue and why they liked the topic.
We had two of our team members take a week to research 3 of the ideas that seemed most impactful to ocean exploration, and our team voted on our official research topic. The problem we chose to solve was coral bleaching, so we set out to find a solution to help prevent coral bleaching.
After researching coral bleaching and prevention methods, we consulted with several experts to validate our solution. Katie Cooper, the CEO of Scuba International, validated its significance. Shannon Dixon, a PhD biology student at the University of Ohio, gave us detailed information on how shading can help prevent bleaching. And Bryce Schaefer, an aerospace engineer who helped us refine our ROV and shading device designs. The NOAA talk provided the first teams inspired us to incorporate AI into our design.
The problem we are addressing is coral death due to coral bleaching. Coral bleaching occurs when corals expel the symbiotic algae they rely on for survival due to temperature changes, pH levels, and UV rays. Coral is a keystone species, meaning if it didn't exist, 25% of all ocean habitats would disappear, ecosystems would be disrupted, the fishing industry would suffer, and coasts would be eroded.
Our solution to this problem is the creation of an ROV that can work alongside multiple large, independently moving shading devices that migrate over large coral reefs to shade large groupings of coral. In Clearwater Reef specifically, we estimate that it would take about 1,300 shading devices that are 30 feet by 30 feet to cover the whole reef over a 12-hour period, with each chunk being shaded for about 3 hours. Even though this is a very large-scale project, we're planning to start with about 25 shading devices and 5 ROVs. These ROVs could be automated or manual, requiring a controller depending on the circumstance.
We designed and created an ROV using PVC piping. The ROV has motors for back and forth and vertical movement, 2 cameras with AI integration, and a waterproof box in the back for electronics and weight distribution. The PVC pipes carry the necessary wiring. Additionally, in Blender we rendered a rough design of the shading device in ROV and then animated those devices in Unity. Here it is in action.
The ROV and shading device will stay in the water, facing wear over time. To prevent this, we'll use high-quality materials, protective coatings, and sensors to monitor issues like overheating. If a problem is detected, GPS can guide a technician for repairs. To handle rough waves, sensors and inflatable floats will stabilize the device, while the device's flexible arms allow for slight movement in changing water conditions. The ROV and shading device will come in 3 sizes, 7.5 feet, 15 feet, and 30 feet, for flexibility across different reef conditions.
The estimated grand total of one ROV is approximately $4,000 and $4,000 per shading device. The estimated power consumption of an ROV is about 2,900 watts every 12 hours, which is also how long it would be operating in full before going in battery saving mode for the night, and the shading device takes up about 3,750 watts every 12 hours. Our shading devices are able to make up about 6,600 watts of power, assuming it is a sunny day for all 12 hours.
To identify coral, we used YellowV5, which is an AI model trained to identify objects and images, and in our case, it will help us identify the coral species and assess their health. The current version is free, but a new version is coming out soon, which we would have to identify the cost of, as it has lots of features that would be useful for us. We're also currently looking into photomosaics, which is a long-term transformation within the coral reefs.
To fund this project, we contacted organizations like SeaWorld, Coral Marine Aquarium, and Tampa Aquarium. We also plan to apply for grants by presenting video demos, detailed models, and project plans to potential sponsors. The project's focus will be on its environmental impact and long-term benefits.
We plan to pilot this project at Clearwater Reef near Puerto Rico, which is perfect for our pilot project due to minimal human interference, significant sun, and an existing bleaching problem. To protect against boater damage in busier areas, we will use reflective materials and issue warnings via mobile apps and radios. The devices will also have cameras to identify violators and issue fines. In case of severe storms, the devices can relocate to safe zones. Thank you for listening. Do you have any questions?